Okay, ladies and gentlemen, let's look at this ACI concrete tensile strength test research, or rather, just search. And if you do that, you'll see the 10 to 15% of the compression strength. You'll see the different people stating it. You'll see civil engineer forum stating it. What else you got here? Tension in concrete. You'll see the math there. What else we got? Engine tips, about the same thing as the formula above, it looks like, roughly. Or this one, and trying to use that formula there. Now, with that said, this is contrary thinking than what I'm going to tell you now, or contrary statement than when I've been wanting to do this for some time, than what, and I've done a few of them now, but I want to get it out there even more often now. What is his name? The guy, the gravity guy. Oh, yeah, Isaac Newton. Isaac Newton says equal and opposite, and equal and equal, right? Equal and opposite. Equal and opposing. Equal and opposing. So if this is your compressive strength on your beam, and you're stating that your tensile strength is 10 to 15% of compression strength, then you're stating what? You're either not telling me the opposite testing you should be doing. In other words, if this is compression, maybe the opposite is not tension then. Opposite of compression apparently is not tension, because this is 10 to 15%. So it's not, and that's even unreinforced concrete we're talking about. So so it's just concrete throughout. So either Newton is wrong, which means equal and opposite doesn't exist, or Newton is correct, and they're taking the sample at the wrong location. So or the opposite of compression is not tension. That's a question. Either that, or the opposite is tension, and they're not finding the correct opposite part, the part that's actually should be playing a role. That would be so equal and opposite, and you're supposed to have a neutral axis where you can put a load here, and the load's down here and then flips over to the tension side of it. But they're not. I state it is equal and opposite, but at some point you've got a hanger like this. If this was cable, then the forces are changed from the load here is not the same as the load here or here. Putting a load on it, the stress is different than putting a load here. Putting a load here compared to here, the stress is different. And so I'm stating that their testing is wrong. That if you were going to go with the and let's do a little more aggressive than that. Yeah. Yep, let's try that again. So that the testing is wrong. So there's a compressive side, but these are also, as you can see as I exaggerate that, well, that's a hanger also, isn't it? So that's a part of the tensile ability up top also, I state. That it's created, and that's the exaggeration of it. But there's the mirror of that one. That's a hanger. You know, right there is a hanger. That's a hanger. And our load is here. So maybe they need to reevaluate where the sensors go to check this loading and find the tension here, 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 and wherever it is. You're going to need a lot more testing locations, because this proves that Newton is wrong on equal and opposite, and it also proves that he possibly is wrong on your gravity people, saying that about gravity. I know it's your program, it's a conclusive file you have, but it's equal and opposite. You can't have a one-way force or it doesn't work, does it? So it's just simply the pressure above, the atmospheric pressure above is equal to you maintain your that's a longer video. I've spent 8 hours on a video once with you guys in a live cast on that, using NASA and everything, talking about the ozone layer, how it opens and closes through the year, and I showed you their own results. Look, this is a perfect planet, but it's a hot son of a gun, and they got to release some air, and that's why we need the ozone layer to be open, and it's flexible. It opens and closes. But I'm stating that the tension is equal to the compression in concrete. Just because they're measuring in the wrong place doesn't mean it's true. So this is a tension side, because think of the hanger, the cable. Well, that's the load there. This becomes a hanger, doesn't it? Same thing here and here and here, of course. But we don't calculate that because everyone's just flatly saying it's compression up there, up top. And that's because of its folding over. But the load is still here, and it's still being, mostly when they point loaded here and here, and then point loaded in the middle, let's say, you got 3 points of reactions. This is pushing up, if you will, as it pushes down, and that creates a compressive moment there. But this is also pushing down, creating a strain this way, which is a pulling effect here. But we don't see that fracture there. We don't see that there unless you look at it in the column format. And now we'll talk about punch shearing. I'm trying to stop it. Okay, so much for that. Now all of a sudden when you look at it, okay, that works for me. So when you look at it in a column format, here's a column. Oh, well, hell, I can put that underneath here then. Let's run a column through. Let's run a column here. You can see that the tension side is pulling inside this column internally. If it's sitting on top of it, then it's pulling on the anchorage. The anchorage that ties it down. Say it's an L-shaped reinforcement like that, 90s. Let's say it's pulling on that, and that's being strained in here. So even though it's being pushed down, it's also being a negative moment pushing it up, pulling it up. So there's a moment that's pushing it down. There's also a lifting aspect to that also. I was going to show you that I spent some time researching compression tests of what? Rings. And a ring has a lot of story to tell about how it fails and how it will come into a crown in here because of the surface tension here. But I'll get into that in another video. Different types of rings and compression failures. So what I'm driving at is this tension is not simply where this civil engineering form mentions, is that their compression, they have because the load is coming down here as it states the load, they're assuming that this is all compression here. Whereas it's going down, it's also pinned here. Think about the ring thing I'm going to show you in the future. It's pinned there, so it's actually trying to hold it back like this thing here, like the 90. And if that's the case, it's in tension at that point. Just because you can't see it doesn't mean the forces aren't there. So it's tension in that point, and this puts I'm about to say Pascal, keep Newton back in play, saying equal and opposite. So I'm saying just because you see a reading up here that says 10 tons, all right? Just because you see a reading that says 10 tons, it's equal and opposite. So it's failing at 10 tons. I'm saying it's not failing at this, what we're supposed to stick to, this tension part. Now, you can increase its resistance by putting the steel in there, but it's still going to be equal and opposite. It's still going to be equal and opposite. You've made it more rigid. It's still going to be the same thing. You're going to find equal and opposite based on the, I was going to say formula or cookbook, the mixture you made, and that includes the concrete and the steel placement, and that's your cake mix. So whatever your cake mix is now will still fail the same. The same tonnage. When you get your deflection, it's still equal and opposite is what I'm arguing. Equal and opposite. The concrete is not weak in tension. It's equal and opposite, and the measurements are all wrong, and that's because they're discounting, not counting the surface tension and friction that this stuff is creating. You need to get some. You'll see the tensions in there. You'll find the equal part, or you'll find that Newton is wrong. Newton's third law about equal and opposite is wrong, considering that tension, as all engineers always consider tension the opposite of compression. You'll find it. He is wrong if this is only 10 to 15%. And I'm saying Newton is not wrong. I'm saying that the current engineering thinking is defective. All right, what do you think, guys? Hopefully this comes across and going from there. Bye.